Good morning, everyone. So, last we discussed about your conversion from NFA to DFA. So, this class, what we are going to see is we are going to discuss about new automata for NFA with epsilon moves, otherwise epsilon NFA. Okay. So, we already discussed what is an epsilon. An epsilon is nothing but a null string or empty string. Okay. When an automata allowing you to make a transition without receiving an input, that is called as your epsilon moves. Okay. So, that is called as your NFA with epsilon moves. So an NFA, so I can make a definition like an NFA which is allowing you to make a transition without receiving an input is called epsilon NFA, or the other notation is NFA with epsilon moves. Okay. So it can be extended to include transition on empty string called as extended NFA. We'll be seeing that very shortly. So let's see how I can represent this epsilon NFA. So this is a formal representation. So it's again a 5 tuples. Okay, it's like same thing as that of your NFA. We'll be having 5 tuples. Q is nothing but your set of finite non-empty set of states, and your the sigma is called as your alphabet, and del is called as your transition function. This is start state, and this is the final state. Okay, so and here we can see this is your set of states, initial set of states, and cross Cartesian product sigma. Sigma is nothing but alphabet. Here sigma includes your epsilon. That's the meaning. Here sigma includes your like epsilon. Okay, we can have, because we'll be moving we'll be making a transition on the given input symbols like a comma b. But here I can include this epsilon as the input symbol, that I can make a transition. Your q naught is equal to your start state, and f is the set of final states. Make a note of this formal representation of your epsilon NFA. And okay, so we have some properties of this epsilon NFA. Let me tell you first, before that, before seeing all these things, let me tell you, we have a concept called like first we'll see what is the use of this epsilon NFA. Epsilon transition used for combining your smaller automata into larger ones. Okay, see here I have one automata and this is another automata. If you want to combine, I can use simply a epsilon transition and I can make a one state in the beginning, so that I can combine these two smaller automata. Okay, the machine, okay, yes, this is for A star and this is for B star. That's what the meaning. The machine combines a machine for A star, any number of A's, and a machine for B. I can easily integrate these two using the union with the epsilon moves. The first thing we need to discuss here is epsilon closure. Okay, so epsilon closure, for example, any state, you can find epsilon closure of any state. You can find any, this is nothing but any state. Epsilon closure of Q is nothing but any state. Okay, so how is nothing but state of all states which are reachable from Q on epsilon transition. You need not worry about the rest of the terms. Okay, so what are the states I can reach from Q on epsilon transition? That is called as your epsilon closure. Okay, so let's see an example. Okay, so let's see at the epsilon closure of each state. Okay, see here how to find the epsilon closure, because why you are seeing this epsilon closure is hereafter we'll be doing epsilon closure for each and every state for conversion of NFA to epsilon NFA to DFA and so many things. That's why we are seeing this epsilon closure. Okay, see here epsilon closure of Q naught. Okay, first of all, when you are going to write this epsilon closure of any state, actually it means what? You can move to any, you can move to state without any input string. So like you can move to Q naught itself without any input state. So when you are saying epsilon closure of any state, just include that state first, because I can move to the same state without any input string. Just include that state itself first. Okay, so Q naught on, just see from Q naught, search for epsilon moves from Q naught. Here we have one move like this. On epsilon it goes to Q1. Okay, again in Q1 if we have search for epsilon moves, here we don't have any, so we can skip. So we just conclude Q0 and Q1. Say for example, I am assuming, for not for this problem, I am assuming if you have a epsilon transition like this, okay, something like this. So what we can do is, the epsilon closure of Q0 is first Q0 on epsilon goes to q1, fine. Again just search for epsilon moves on q1, is q2. You can draw like this, you can write like this. Okay, so just keep on searching for epsilon moves on the states. Okay, so epsilon closure of q1 is nothing but q1, because we don't first I need to write the state itself. Again we don't have like forget this one. Okay, so again we don't have any epsilon moves on q1, that's why q1 alone. Okay, okay, if epsilon closure of each state. Now q naught, okay, you just consider q naught first. I have to take q naught first. On epsilon goes to q1, good, q1, let me write q1. After that q1 doesn't have any epsilon transition, just finish that. For epsilon closure of q1, again the first that state itself q1, and we don't have any epsilon moves from your q1, so just conclude with this q1. For epsilon closure of q2, just write that first state first, and we don't have any epsilon moves from q2, just close with your q2. Same thing. Okay, now do this q naught, epsilon closure of q naught, nothing but just take I'll be first taking your q naught, and then on q naught on epsilon, like we have a epsilon move. Okay, just epsilon move, I'm just going to q1. Again search for epsilon moves from q1, we have that one to q naught, so q naught. What about q1, epsilon closure of q1, nothing but first q1. On q1 just search for some epsilon moves, yeah, here we have, so it is going to q2, so it's q2. Like this we need to define the epsilon closure of each state. Okay, so this is the epsilon closure of each. Just this is your transition table, actually this is your transition table they have given. So on transition table you can see that sigma, in sigma here nothing but I have three things, a, b and epsilon. The input empty string also we have just included. Okay, so p on sigma goes to s, p on epsilon, okay, p on epsilon goes to s, p on a goes to no transitions, p on b goes to q. See here, first let me consider this one, let me solve this first one, epsilon closure of p. So epsilon closure of p, fine. So first I have to include the state first. Okay, p, let me start. P, just search for this this thing. Okay, p on empty string. So p on this epsilon, it goes to s. Okay, let me take then s. Okay, now come after s, we need to track the epsilon moves from s. Now yes, track for, now yes, search for epsilon moves. Yes, we have an epsilon move and it goes to q and r. QR, this is state. Okay, so on q and r we don't have epsilon moves, on q is going to be null string and this is q already, so this is pqrs. So try for this epsilon closure of s. Yes, on epsilon goes to qr. First of all I have to write the same the state s, and try to see now on s, on epsilon moves, let me highlight, on epsilon moves here, on s it goes to q and r, and q and r is nothing but again from qr you need to see the epsilon moves, that's why I'm going here. Okay, so again same side, this is no transition, this is q is already here, so likewise you need to find out. Okay, again these are all epsilon closure problem. Just try to find your draw the NFA epsilon. This is the NFA with the epsilon moves. Otherwise you can say epsilon NFA. Why I'm calling this as epsilon NFA? This is because we are having a transition for null string here without any input string, because I'm not marking the input string a and b. This is a null string. On null string it's going to another state. Okay, this is epsilon NFA. Try to draw this epsilon